So, now it's time to do the height-based mask dissolve shader. For that, we're going to keep an alpha clip material. We're going to keep the noise mask. We're going to keep the emissive mask and the color blending, but we are kind of getting rid of the dissolve amount value, and it's going to be controlled by the height-based mask. And we are going to have two new variables, maybe three. It's like the distance mask, but we are not going to need a C# script. So here in Unity, we are going to do exactly the same that we did before. We just going to duplicate the basic shader that we had because it's just working on top of that. Instead of my basic dissolve shader is going to be my height dissolve shader. Okay, let's create a new material, also called my height dissolve. Apply it to the sphere and link the shader. Shader grabs my height dissolve shader. Okay, and open shader graph. Okay, so this is the shader. The height dissolve shader is copied from the basic dissolve. So we are going to keep all of this, kind of these parameters around here. We are going to keep all these variables. That's okay. And first, instead of just messing around and so on and doing things in advance, I'm going just to remove this and the emissive. Yeah, and I'm going to build the height-based mask. Let's do the mask, then blend it with the dissolve, and we already get the effect. It's always the same. You already have the dissolve effect. Just generate new masks, combine them, you get a new effect. So first, I'm going to create new variables. I need two. Later, I will parameterize another one. So yeah, I'm going to create the first two. They are just numbers, vector ones. The first one is going to be an offset. The second one is going to be another number. It's going to be called height. The idea is that with this, we can control, let's set this to offset 0 and height just 1 by default. And on the preview, let's put here a capsule so we kind of see it. The idea is that this, if you have a model that the pivot is at the base, you don't need offset, but if the pivot is at the center, you need to offset a bit this in order to work. There are a lot of ways of doing this. This is just one of them. So we're going to create a mask, a height mask. So first we need the position. Okay. Now we are going to change a bit. Instead of getting the world position, we are going to get the object position. So we just compare it to the object, not the world. Otherwise, you get a height mask based on the world position. You move the object up and down, and it just changes. Later, I'm going to combine the offset and the height and just feed it to the emission so we see the mask and explaining a bit. First, we need to combine the offset. We just add the position because it's just an offset. So yep. We add the offset, and now since we are going to work only with the vertical, there is a lot of ways of doing this with less parameters, more parameters, different ways of making instead of just a vertical based mask. You could do it to the sides and so on, but I'm going to split this vector 3 and just keeping the y coordinate, which is the height or the g, right? And I'm going to divide this by the height that I want to make the mask. This will give me a gradient okay, will give me a gradient to the height that I'm setting it. So just put it to the emission. We already have something here. So we have a gradient here. And for example, the pivot is here. This means 0, and this is the height that you have there. And if you want a little bit of offset, just add. I think it's 1.25. No, it's a bit more. 1.5. Maybe it's 2. Yeah, it's 2. Yeah, it's completely 0 here at the base, but it's white on here. And then later, depending on the height, one means the whole body. And if you just set 0.5, it's lower. And if you just set 2, or maybe a bit more, 4, yeah, you just go increasing it. It doesn't have a true value. You can see that the grading is changing, and that's the idea, right? But every time that you have a mask with a gradient and you want to control the gradient, a cool way of doing it is using the power function. And look here, if I just increase this to 50, for example, and creating a hard edge, and then you can just, play with this a bit. 4 is at the top. If you decrease it, like, in order to test numbers, I'm going to get rid of this. I'm going to show you a nice way. Just put here a slider, and we know that 4 is the top. So now, there you go. Now we see it on action, right? It's like, yay, 4 is top, 0 is the bottom. So this is a mask. We already have this. So the idea is, now that we have this, yeah, we have to, instead of using here a slider just like that, we have to use the dissolve amount that goes from 0 to 1, right? But as you can see here, I'm making a slider that goes from 0 to 4. We can remap this. So what's the idea? The idea is I just remap this value from the range 0, 1 to the range 0, the height of the object. I know that the height of this object is around 4. That's something that we adjust later. We apply this to a mesh. We have to set an offset of the pivot of the object and the height of the object, so we can get this nice effect from 0 to 1. It's just normalizing it. And yeah, height is an artistic value. It will vary from your models, and also, as well as offset. So in order to make this is a vector 2. The thing that we have here is a vector 2. So we just create vector 2 here, and now we can plug this thing to the range from 0 to the height. So just by doing this, we kind of get this effect, but the slider is 0, 1 is fed to the remap, and the remap is translating it to 0, 4 like we had before. So yeah, it's okay. So another thing that we have to think now that we are here, let's bring back the slider again so I can just finish explaining with it. The idea is use this as the dissolve, the value that we were adding to the previous mask here. We were just adding here. So we were adding a value from 0, 1 and so on, but we need to clamp this first. And maybe we need a bit of uh, adjustments, right? One of them is going to be that this value is inverse. Why? I want this to go from when it's 0, I have to this I have to add 0. When it's dissolve amount is 0, this has to be 0. And when it's 1, this has to be completely white. How do we achieve that? Since this value is inverted. I'm going to do it on the slider, but it's just the operation 1 minus. It's not going to work here at all because 1 minus works when the value goes between 0 and 1. It also works to invert a mask. We already use it to the border of the dissolve, I think. No, no, we haven't used it yet. But it's used to invert a mask. So now with this, it's like having the slider going from 4 to 0. Sorry, yeah, no, yeah, it doesn't work. I cannot have a slider that goes all the way around here in Unity. But yeah, anyway, by doing this, I have it. So just trust me. So the idea is instead of we clamp this, okay, it's completely clamp, and with this power we control how long is going to be the gradient. 50 is kind of okay. So yeah, this value here is an artistic value, but because maybe we want this to change and get different gradients and so on. I really like to have this as a parameter. This is the third parameter that I told you that we may use. So I'm going to create a new parameter. Let's call it some number mask gradient. So yeah, you could, you know, adjust gradients in a different ways. I usually use the power, but you could use a multiply or a combination of multiply and power with parameters so they get exposed and then you can later use them. So let's group all of this, group selection, and let's call it height mask. It's a mask that it just works with the height of the object, a little bit of offset, and a normalized value between 0 and 1. That's it. And you can adjust the mask to any object of any height. Next step, mix, how do we blend the mask with the previous dissolve mask? Okay, let's just do this in this way. I'm going to add this and B instead of adding 1.001. So it says, oh, it's not adding 1.001. Okay. And then I'm going to multiply. We multiply the mask, and this goes to the alpha clip, and this goes to the emissive. Let's put this thing in order a bit. And the emission goes here. Perfect. So I have my hive mask. Let's put things together, zoom in a bit so you get to see everything because it's super small even for me. Offset, I like to put it here and put things together. Not that much, not that much. Okay, yes. Ta, 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 ta. So this is our hive mask. Position, adding plus offset, getting the vertical axis. If you get the right axis, you will get the same mask, but in the right axis, or the forward axis. That's your choice. This is a height mask, so vertical axis of the object. We get the vertical axis, divide by the height, but you have to understand that the height is controlled by a normalized parameter that goes from 0 to 1, remapped, and so on. And then this is outputting a gradient and controlling how sharp is the gradient, clamping the values, and ready to go to mix it with the dissolve mask, and then again dissolve, border, blah, 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 color, and so on. So let's see. What is my mesh? It's not here. So yeah, it's here. Dissolve shader. I think let's oh no, border size. A few things here are off a bit. Mask gradient 50. Okay, so mask gradient was the value to adjust the mask. 50, the offset was 1, and the height is 4 or 4.5, kind of. And then, yes, we have a dissolve here, height-based dissolve. Doing a bit of math, you could change the direction, but yeah, it's the same for both. Yeah, we have a problem with the border. Too much. Yeah, this border size is negative because I haven't remapped it and adjusted it. So let's have a nice glowing, sorry for that, I just hit the mic. Nice glowing border. And yeah, with the noise scale, we can play a bit and get, more irregularities on the high mask. And that's it. Super simple hide mask based dissolve shader. This is the last exercise of the tutorial. I hope you like it and I hope that it's useful for your projects. Maybe you are asking yourself, where do you go next? Can we do better effects from these examples? The answer is yes. Here there is another dissolve effect, but this time using a texture as a mask. With this, you can author your own textures and get custom effects. You have to think that you always need a number between 0 and 1 that will define how your mesh is going to dissolve. And don't forget that you can combine multiple masks to get a new effect. In this case, I have combined a height mask with a texture mask for a nice effect that could easily fit an energy shield powering up. A lot of people ask me where should they use this kind of effect, and the answer is simple. You can always use this effect to make an object spawn or despawn in camera, with a nicer effect than just popping in and popping out. And even more complex effects, like the distance-based one that can be used for interesting game mechanics. But what about real games? The big titles out there. They also use it. Like in World of Warcraft, they started using the dissolve effect in the Legion expansion for the demon spawn effect. It is always subtle, but you can see that a basic dissolve effect is in place. Also, you can find this effect as a part of one main effect of a game, like in Breath of the Wild, where you get this after every sanctuary. This effect is super cool, and the particles that are emitted from the borders of the dissolving mesh are just even more spectacular. So, what do you think about dissolve effects in games? Are they worth using them? Or are they just a niche effect for sci-fi games? Let me know in the comment sections below. I hope you like it and stay tuned for more content. Thanks.